Mhm. All right, I think it's recording now. Awesome. Okay, great, guys. So I think you guys can see my presentation, right? Let me know if you guys can't see it. Otherwise, I'll get started. Okay, cool. So today we're going to be talking about the echoes of classical Indian linguistics in natural language processing. This is a subject I'm like really interested in, seeing what the intersection is between these like super ancient kind of texts and like stuff we're doing at the cutting edge of AI today. So just to get a bit of an overview for me, I'm actually an intern on the data experiences team in Azure ML. I'm building like a compute list named entity recognition prelabeler for AML labeling. I study cognitive science at CMU. And like my personal kind of like relation to like this whole field is that I have like a lot of past research in NLP. So I've worked with dialogue, summarization, question answering, all those kinds of applications, as well as with more theoretical interests in like syntax, and visual grounding, which is what I'm writing my senior thesis on this upcoming year. I've also been studying Sanskrit for like about 4 years now, and I built Veda.dev, which is basically an education slash research tool for reading like classical, like Vedic literature. This past semester, I also taught the classical Indian philosophy class at CMU, and that was really fun, and we sort of talked about various topics somewhat like this. So I also want to give some general kind of goals of this talk, right? So the one like the first thing that we're going to want to do is like see how classical Indian thought has influenced NLP. And I'm actually going to draw out like a intellectual trajectory by which we can draw a direct connection between work in NLP today and traditional Sanskrit literature. And we're also going to want to understand some broad tensions in NLP research today. So these are stuff that people are talking about at the forefront of AI, the whole tension between symbolic versus neural, as well as syntax and compositionality and what those words might mean. I also want to depart from a Eurocentric view of intellectual progress. Often we sort of think that NLP was developed entirely in Europe or in the West, and the same goes for linguistics and basically computer science. But like I'm going to talk a bit about how these intellectual like studies might have broader origins. I also just realized that I don't have my camera on. Let me turn that on as well. Okay, there we go. Um, and then finally, I want to deepen connection between our identity and work. So for me personally, like seeing the connections between like classical Indian literature and like NLP, it brings a lot more meaning to my work that I do in NLP today. Um, it's almost like I'm just continuing the same kind of research work that like intellectuals in South Asia have been doing for over like 2,000, 3,000 years. Um, so with that, let's get into our first kind of quote. So the linguistics of India more than 2 millennia ago was the direct germinal origin of the linguistics of the West today. Can I get any guesses for like who might have said this? Um, any guesses? Feel free to raise your hand or drop it in the chat or say it out loud. Any guesses? Any guesses? Okay. Uh, so this is by the actually the founder of the UC Berkeley Linguistics Department, MB Emino. He was the president of the Linguistic Society for America and various other kind of linguistic organizations. And he said this in 1955. So in the early 1900s, like you can see definitely by 1955, people were definitely understanding how important the traditional Indian linguistic tradition was in the what and its contributions to the West. But it turns out that this had also been the case for about like 150 years before that. So starting in 1786. Sir William Jones conjectured the Indo-European language family after learning Sanskrit from like a traditional Vedic teacher. Over the course of the 1800s, historical linguistics, like the field itself, was developed and Indo-European theory is formalized. And for those of you who don't know, Indo-European theory is like a broadly accepted kind of like framework today in anthropology, which basically suggests that the languages of South Asia, Iran, and Europe all had a common origin in a language called Proto-Indo-European that we don't have any direct evidence for, but we have reconstructed evidence for. So when we take a look at all these languages, it suggests that they share a common origin that was spoken around 2,000 or 3,000 years BC. And then in the early 1900s, there was another school called the structural linguists that sort of grew out of historical linguistics and their study of Bhartrhari, which is like a specific like he was like a Indian linguist working around 500 or 600 AD, gave rise to the field of semiotics, which was very kind of widespread in structural philosophy and structural anthropology. And then in 1965, Chomsky, which you guys might be more familiar with, built on the Ashtadhyayi using recursive grammar. So it doesn't seem that he directly drew that much inspiration from this work, but he was certainly aware of it, and it was certainly widespread knowledge that this was a generative grammar, which we'll talk a bit more about in the next few slides. But his key contribution was adding recursion, which the Ashtadhyayi didn't have. But it is widely accepted that this book was the most like cutting edge in terms of generative linguistics or like syntax until like 1965 Chomsky's work, which is kind of crazy if you think about it. Like it was state of the art for like 2,500 years, whereas like modern like machine learning models are state of the art for maybe 3 to 6 months. So what is syntax, right? So syntax is this idea that like a vocabulary alone is finite, but if we combine these words using rules, we can produce an infinite amount of meaningful sentences. And it turns out what the Ashtadhyayi has, the Ashtadhyayi was written by this guy named Pānini, working around 500 or 400 BC. And it turns out that you can generate every valid Sanskrit utterance using just the 3,959 rules he has in this book. So he basically presents this list of about 4,000 rules and then a list of a bunch of root words and some like elementary sounds. And using those three tools together, you can generate every single possible valid Sanskrit utterance, and you can't generate any syntactically or morphologically invalid Sanskrit utterance. So this is like a generative grammar. It's called a generative grammar because using these formulaic rules that are outlined in the grammar, you can generate every possible grammatical statement. So let's take a deeper look at the Ashtadhyayi and how it actually works, because the structure of it is very interesting. It had puzzled people for a long period of time, especially like Europeans when they arrived. They couldn't really make heads or tails of how it worked. But with the rise of like computer science, really, it became a lot clearer, and they were able to formalize more clear models of how this set of 4,000 rules actually works. So let's take a look at this one specific situation, vowel sandhi. But before I go into that, I just want to pause and ask if there's any questions. I can take questions right now before it gets super complicated. Okay. All right, don't worry. It won't get super complicated. I think I've simplified it to a fair extent. So vowel sandhi is this property of the Sanskrit language in which vowels that sit next to each other sort of combine. Sandhi literally means to put together. So an example of this in English is when we say like gotcha, right? Like got you, the T and the Y combine and you get this cha sound, gotcha, right? So a very similar thing happens in Sanskrit, and there's a whole set of rules in the Ashtadhyayi which describe how those sandhis happen. The specific situation we're going to look at is vowel sandhi, where you have two vowels that sit together, and then they change in their sound. So an example of this is Draupadi Ashvam Ichhati, which becomes Draupadyashvam Ichhati. So you can see this E over here becomes a Ya over here. We get Draupadyashvam, right? Pretty straightforward. And then also we have Madhu Asti becoming Madhu Asti. You can see this V, like the U basically turns into this V, just as this I basically turns into this Y. Pretty straightforward. How do we actually formalize this though, right? How can we like write a rule that describes this? It seems pretty straightforward, right? We can just say if we have this I, it'll turn to a Y if it comes before another vowel. And that's basically exactly how Pānini defines it. The rule he has is when we have samhita, which means like sandhi. Sandhi and samhita are basically synonyms. They actually both come from the same root. Um, in samhita, um, of ik, there is yan in ach. That's what he says. Iko yanachi, which is very strange. Ik, yan, and ach are not words in Sanskrit. Like without knowledge of the way the Ashtadhyayi would work, this would sound somewhat nonsense in Sanskrit. Ik, yan, and ach, in fact, are not traditional Sanskrit words. They're actually these things called it letters or it symbols. And the way they work is that they symbolize or signify certain sets of sounds. Um, so what we said was that we want to turn the I into a Y and a U into a V when they come before a vowel. And it turns out this is actually what this rule says. Um, so this ik basically stands for an I or a U. The yun stands for the Y or a V, and then in ach basically means when it comes before a vowel. And the way this works depends on this other this list of sounds that I mentioned earlier, right? Called the Shiva Sutras. The Shiva Sutras are a set of sounds where we have these it letters at the end. So this na, ka, na, cha, these are all called it letters. And the way we go about constructing these it symbols, right? This ik and yun, for example, is it's basically like a contiguous like a subset in an array or like a splice. It's like an array splice, right? So for example, ik, right? Ik basically means you start at A, so we go to I over here, and then we go all the way to the next ga. So we say E u, then we skip this na because it's just an it letter. It's like a pseudo symbol. It's like a marker. And then we go to and then ga. Um, so then basically what this signifies is E u o. Yeah, that's it, right? It's just this this splice of this overall array. So this ik really stands for e u o, and and o in Sanskrit are these are actually vowels. Like some people in modern Indian languages now pronounce this ri or lri. That's actually incorrect. They're both vowels, so this is an and this is an o. Um, and then they turn and then the other thing we want to see is this yarn, right? Um, what is yarn? So can anyone take a guess for yarn? I already sort of told you the method for going from the symbol itself, right, like ik, to the actual sequence of sounds. So can anyone guess what yarn stands for? Like using this table, right? Try to construct the list for the vowel for the sounds symbolized by yarn. Anyone want to take a guess? Just unmute and go ahead. I can give you a hint, right? So we're gonna want to start with the ya sound, which we find over here. Um, so for yarn, we start over here, ya, and then we go all the way until the next na, which
Where
we
you
can
point
see
at,
is
Omar?
over here, right? So we say ya, va, ra, skip da, then we get la, na. So now we have this list for yarn, which is ya, va, ra, la. So ik stands for e u or o, yarn stands for yavara la. And you can already see that there's like a connection here, right? I didn't put the yarn symbol on this expansion on this slide, but e becomes ya, u becomes va, becomes ra, o becomes la, right? So it's like a direct mapping, right? Both of them are for long, and both of them, and like the ik are for the vowel versions, and the yarn are for the consonant versions. Now ach, right? Uh, does anyone want to take a guess on this? What is this? What is the sequence symbolized by ach? You can just do it based off of this table, right? Anyone want to take a guess? Guesses. Okay, so we start with right over here, and then we go all the way to da 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 cha over here. So we get ach. And that's basically all the vowels, right? I, U, O, A, O, I, Au, cha. Um, so ach stands for vowels. Um, so of ik. Oh, and let me explain this as well. Basically, the way Sanskrit works is it has this nominal case system. So when we say ika, that means of ik. Um, and then achi, just ach over here means vowel, but then I over here means in ach, right? It's the locative case, which basically, so the way English works is that we add these prepositions, right? Like in something or of something, above something. The way Sanskrit works is that you actually just add these suffixes to the ends of your nouns. So of ik, there is yarn in ach. But what actually do these of and in actually mean, right? Like it's sort of confusing what like it's sort of ambiguous based off of these noun cases, how to interpret this of ik or in ach. We intuitively want to say that of ik means like uh getting away from ik, right? Like of ik, there is yarn, right? So we're replacing ik with yarn in ach, right? And in ach means vowels, right? So we want to say like before a vowel. Um, so it turns out they have Pānini writes these meta rules. So this entire chapter 1.1, he has this like several meta rules which define how the grammar itself works and what the noun cases mean in the grammar itself. So, for example, this sutra Shashti Sthane Yoga basically means Shashti. So the sixth case, is the genitive, which is like ika, right? Of something. That's what shashti means. When we say of a word, that signifies sthana yoga, which means in the place of. Um, oh, sorry. This is a. Oh yes, yeah. Sorry for the genitive, right? So in the sixth case, when we say uh, uh, of something, we're saying to replace that, right? In the place of. A lot of you who speak South Asian languages know this word sthan, right? Sthane yoga. Yoga literally in this case literally just means like enjoining. So in the place of like enjoining or in the place of like putting. Um, so that means that if we say of ik, uh, then we're saying replace ik like with or put something in the place of ik. And this other rule is tasminiti nirdishte purvasi, which means when the seventh case is specified, tasmin is in the locative. It means in that. When we say in something, then it's referring to the previous thing, right? So the substitution is of the previous element. So when we say achi, right, we mean in like that literally means in the vowels, but this word purvasya tells us that we have to replace the sound before it. So when something comes before a vowel, then that's what we're replacing, right? So let's like based off of what we learned over here, let's go back to this rule. Interpreting it with all these rules that we've seen, we can interpret this as an ik vowel is replaced with, right, because it's in the genitive case of ik. We're replacing it with something. Yarn is just in the nominative case, which means it's like sort of not marked. It just means that something is. It's the subject. So we replace it with yarn when a vowel follows, right? Achi means we replace the previous thing, the previous sound. So we're saying an ik vowel is replaced with the yarn when a vowel follows. So that just means eu or o becomes yavara la when the ik sounds comes before some vowel, right? E, u, a, I, etc. And this is basically one sandhi rule. So it happens in samhita. Um, One kind of ambiguity here, though, is that how do we know that the I sound maps to ya and the U sound maps to va, right? How do we know that it's a one-to-one mapping instead of just mixing all together? How do we ensure that this is like an ordered mapping, right? Instead of being like several to one or one to several, right? How do we ensure that that is formalized? So Pānini writes a rule for this as well. Yatha sankhya manudesha samanam, which just means that as many numbers as there are, if they are the same size, then they refer to their relative position, anudesha. So if we have ik, right, eu or o, and we have yarn, yavara la, they're both four letters long, so we map each one according to its relative numbers. So ib maps to ya, u maps to va, etc., etc. So now applying all these rules back to our original example, we see Draupadi Ashvam Ichhati, right? We have e, that's an ik vowel, right? And it comes before an ach, a vowel, right? Any like anything like a. Um, so when we have this ik vowel and it comes before an ach, then we replace it with yarn. So the e becomes a ya. So we get Draupadi Ashvam Ichhati. And the same thing happens over here. Madhu asti becomes madhu asti. Um, so I hope that made sense. Is everyone like clear on this? It is a bit complicated, but I hope that I was able to simplify it to a relatively understandable um, uh, explanation. Okay. So as I was saying, this was like not very the Ashtadhyayi wasn't very clearly understood for like the first 100 years that it was known by the West. And it really wasn't until the rise of like computational theory in the 1900s that people were able to really understand uh the way that the text worked. And a lot of parallels have been drawn to finite state automata, as well as like context-free grammars, regular grammars, a lot of stuff that both linguists and computer scientists worked on for like the first half and like the center, like they still work on this kind of stuff, but like this classical kind of computer sciencey stuff it is very fit to describe the ways in which the Ashtadhyayi actually defines Sanskrit sound changes. So for example, we have this set of applications of rules that go in sequence, applying to this phrase. So devasapi turns into devopi, and this happens through the application of these various rules. And you can actually formalize these rules using finite state automata. As you guys might have learned back in college, like there's a direct equivalence between grammars and classes of like complexity classes of automata. So yeah, there's a lot of work on this, very interesting kind of formalizations. And like yeah, like a lot of these rules are also very much look like regexes, right? You have some kind of regex rule and then you apply it to some string, and then you get out an output which transforms it. So yeah, this is kind of the idea with this first half of the talk. It was a relatively simple example. Pānini uses the same system of abstract symbols, meta rules, and scope hierarchies. Here we saw to explain how vowels combine, but he uses the same kind of like computational machinery. Obviously, it's not implemented in a computer, but computer science really doesn't require computers to run. It's the study of how these abstract kind of machines work, right? These like structures, like automata and like grammars, and complexity classes. Although runtime complexity isn't something that Pānini talks about, a lot of these other kind of meta rules and hierarchies, etc., are used by him to explain verb tenses, noun compounding, prefixes, suffixes, and even something like syntax to a certain extent. So like these formalizations, like when we formalize the Pānini's grammar in Western terms, it very clearly parallels the complexity of Chomskyan grammar. And Chomsky, the like another interesting kind of thing is that like Chomsky doesn't really care about the edge cases when he focuses on when he talks about linguistics. It's really just focusing on what is predominantly true. Sometimes there's some weird edge cases grammatically that he doesn't really care about, but Pānini's grammar is actually exhaustive. There's certain rules where Pānini lists out like 8 different or like this applies to all verbs except these 8 specific verbs. And like there's plenty of rules like this where he talks about exceptions and every specific situation. So Pānini like on the one hand is more exhaustive while at the same time being just as general and formulaic. The other kind of distinction that I'll draw is that Chomsky cares more about word order because word order is super important in English when we're talking about syntax. But Pānini more focuses on sound patterns and morphology, the ways in which words combine or these prefixes and suffixes affect each other, which is more important for Sanskrit grammar. So I just think those are more so features of like the specific languages that these linguists were working in. But ultimately, they like I feel like if Pānini was working in English, he would have focused more on syntax, and Chomsky vice versa if he was working in Sanskrit. And so these symbolic approaches, when we think of NLP, we don't really think of them, right? To the layman, NLP today means deep learning, which we're about to talk about. But these symbolic approaches actually dominated NLP from 1960 to 1990, and they were still pretty relevant until 2010. And in fact, like most production grade systems today for stuff like dialogue systems and other customer-facing applications still use these not rules like these necessarily, but still like grammatical kind of definitions as well as like if-else statements and these like graphs for having conversations. So this kind of symbolic approach to NLP where we have explicit rules has been huge for the past 50, 60 years. And it's really only in the past few years that we've gotten into the deep learning era of NLP, where we don't have these explicit rules. We instead have these neural nets that learn things implicitly. So that's what we're about to talk about next. But first, I can take questions again. We covered a lot of stuff in terms of computer science and whatnot, so feel free to ask any questions right now. Okay. Am I going too fast, by the way? Like, should I slow down? I'm not sure if like I'm covering everything, like I'm explaining everything in simple enough terms. Okay, cool. So deep learning, a lot of the deep learning work in NLP is sort of motivated by this idea that we can compute form, right? Traditional symbolic NLP can compute form. Sure, we can get like a sentence out, but how do we know that we actually understand it, right? How do we compute meaning? So there's like symbolic approaches to computing meaning as well, like formal semantics and everything, which a lot of people worked on in the 1970s and 80s. But it turns out that a lot of semantic features, a lot of these features of meaning are better apt to represent vectorially. So what do we mean when we say a vectorial representation of meaning? There's like a vector is literally just a list of features, right? For example, if I say the king, we can draw an analogy from king to queen that holds for man to woman as well, right? There's a bunch of features of king that a queen also shares. It's just that there's this one feature that's different, and that is its like that is the gender. Same thing for man to woman. A man and woman are all the same. Like we can represent most of the features the same. It's just there's one feature that is different. Otherwise, they're the same, right? They both have two hands, two legs. They can speak. Blah 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 blah. And similar things we can do for grammatical kind of situations like verb tense, we can draw these kind of analogies. So vectorial semantics is basically saying that we can represent each of these words in a high dimensional vector space. Nowadays, people work in like 768 dimensions, where you can sort of think of each of these dimensions, each of these numbers in the vector as representing some kind of semantic feature. So that could be color, size, like whether it's a human, whether it's some kind of animal. But the key distinction to be made, or I guess it's not a key distinction, you can sort of abstract this away. And in fact, I think most NLP researchers, when they're thinking about these high dimensional spaces, they do like to think in terms of more concrete kind of features. But these features actually aren't very concrete. It's not like we're going in and saying, okay, a king has two hands, two legs, a queen also has the same. We're not writing these by hand. Instead, we actually learn these features from statistical co-occurrence in a large corpus of text. So basically what we do is we get this huge set of like English words, or not like this huge English text, right? We get like hundreds, thousands of books, scrape all this text from the internet, and we basically train a model to predict words given the word's context. So we might have something like the man sleeps and the woman sleeps. And implicitly what this neural net learns then is to represent both man and woman as statistically co-occurring with the and sleeps, right? So implicitly the neural net now understands, okay, men can sleep, women can sleep, blah blah blah. So in this high dimensional vector that we have, we're now encoding all this relational information for what a man and woman is, right? We get these this meaning encoded implicitly in our vectorial representation. Um, earlier work like earlier work didn't really take into account the context of each word though into its meaning. So for example, if we had the vector for man, it would always look a certain way. But like as you know, right, man can mean different things in lots of contexts, right? A simple example is like when we say um uh like like man as in the male gender versus man as in like mankind, right? Like humanity as a whole. And another example is like like using man as a verb, right? Like I am manning the vehicle right now. Um, those words mean very different things, right? So the question is sort of like how can we change or represent the meaning of a word differently depending on its context? So like if we're using the example of break, right? Break the vase versus break the record, those mean two very different things. When we're breaking the record, we aren't literally smashing it to pieces like when we are breaking the vase. When we're breaking the record, we're like improving beyond like some set amount, which is a very specific meaning, but we use the exact same word, right? So the question is like, how can we like learn these contextual representations from text corpora such that we're representing these words, the meaning of these words as they depend on their linguistic context. Um, so I've given a few examples of how words change in context, and it turns out that this was actually a very large kind of dispute in this school of philosophy called the Mīmāṃsā school in India around 700 or 800 AD. So before we get into like contextual meaning, the question they were early, like the first question they were sort of asking is like, how do word meanings relate to sentence meaning, right? If I say a bunch of words, how do those word meanings then somehow construct this sentence meaning in my head? And they came up with two predominant theories that were developed by the two rival schools, like rival sub-schools within this overarching school of Mīmāṃsā. One school was the Bhatta school, and the other school was the Prabhakara school. The Bhatta school came up with abhihitanvaya, which means connection of denoted meanings. This literally means abhihita anvaya. So abhihita means like denoted meanings, and anvaya means like connection. So we're the connection of denoted meanings. The alternative theory is anvitabhidhana, which means like denotation of connected meanings. So abhidhana means like denotation. Anvita means like connected. So we're denoting connected things, right? We're pointing to some things that are already connected. So based on these names already, you can sort of get a gist of what they're saying. The Bhattas are saying that each word has some denoted meaning, and then we connect them together in our head, and then we get the sentence meaning, which is sort of it's sort of intuitive, right? Each word has some meaning, and then we put them together, and that's how we understand a sentence. But the Prabhakaras have a slightly more counterintuitive example where they say that the sentence meaning denotes the connected meanings, or in fact, maybe even each individual word refers to the meaning of that word as it is already connected to the other words in the sentence, which is sort of counterintuitive, right? Like, how can the word break refer to the entire connected meaning of a sentence? So just like to paraphrase this, right? The Bhatta school, the Abhihitanvaya school says the word meaning the process of denotation, right, like understanding the meaning of a word causes one to cognize the word meaning from a word. Each individual word represents its word meaning. Whereas the other school, the Prabhakaras, say that it results in cognization or like cognizing of the sentential meaning from a word. The entire meaning of the sentence, they say, is actually encoded in the word itself, or at least in part into the word itself. So how could this be? How could this be? First, let's look at the more intuitive example. This, I think, makes sense to most people. Basically, what the Bhattas say is that the entire composite of the words which has been heard causes the memories of their unconnected word meanings to arise, right? So when we hear break the vase, right, break, we go and fetch the meaning of break, then we fetch the meaning of then we fetch the meaning of vase. And then when we hear all of them together at the end, they get put together according to linguistic principles. like basically syntax and grammar. And this causes the sentential meaning to arise. So we put break the vase together according to the rules of grammar, and then now we see the meaning of the entire sentence. The problem here is that if the meaning of break is just fetched unconnected, how can it possibly result in a sentence cognition where the meaning of break in one sentence is different from the meaning of the break in the other sentence, right? Break the vase versus break the record. How does the meaning of break itself change if we're simply fetching this unconnected word meaning? And like the like kind of assumption here is that like the meanings of words exist on their own, right? Maybe we can say that there's some fundamental meaning of break and then it changes depending on context. But here's actually a slide I pulled from a talk at NACL last week, the North American Association the North American chapter of the Association for Computational Linguistics. There was this NLP research conference last week. That I attended, and it's a pretty big NLP research conference. I think it's like the second or third highest cited in the field. And there was a talk by Chris Potts there, who's a professor at Stanford, talking about like contextual meaning and how words influence their neighbors. So I pulled a few of these slides from there. And basically what we're saying, what the implicit assumption here is that there's some core meaning of each word, right? Break, maybe there's some core meaning. But here he actually like pulls up the dictionary entry for the word break. And this is actually a GIF. He's like scrolling through. There's like 40 or 50 different meanings of break, which vary so differently, right? To demulsify, right? Like when we're breaking a cake, like cake batter mix or something, versus like breaking into like the line, right? When we're playing football or something to counterattack, right? Those are such different meanings. Can we really identify some core meaning of break that is then fetched? And even if we can, like how meaningful is it then to talk about this unconnected word meaning if it doesn't have much predictive power? If there's 50 different word meanings that we can derive from this one word break, how meaningful is it to talk about some core of meaning? So what the Prabhakaras say as a response is that these words actually already denote the meaning of the word as it is connected to the other words in the sentence. So for example, so they basically say that in the example gamanaya, which means bring the cow, the word cow they say is connected with the action of bringing, and the meaning of anaya is connected with the cow itself. And the response that the Bhattas then present is that if the meaning of gam over here is the relation of cow to bringing, and the meaning of anaya is bringing to cow, then won't they all just be synonyms, right? Won't all the meanings just converge on the same thing if they're all just like connected with each other? And the response is like a very philosophical kind of response, right? Again, we need to keep in mind that these people are working without like in a society where like empirical research isn't that common, right? Most of this happens as like mind experiments, right? Thought experiments. So all of this does sort of sound a bit hand wavy, but nonetheless, the underlying kind of idea still holds. And the response that the Prabhakara school presents is that in this specific example, the meaning of gam and the meaning of anaya aren't synonyms because the meaning of gam is cow as it is connected to the action of bringing, and the action of bring and anaya is the action of bringing as it is connected to the meaning of cow, right? So these are directional relations, right? We can capture the meaning of each individual word as connected to all the other words in a sentence. It's just that they're going to each encode different kind of directionalities or dimensions. I shouldn't use the word dimensions, but perspectives into the same meaning. So this kind of distinctness, right, in which different words are connected in different directions, ensures that we actually don't have some kind of synonymy situation arise. So taking a step back, like we're basically asking, like, can we elegantly describe in some way how context influences meaning, right? We've had this great debate about, like on the one hand, maybe we have these predefined meanings and they combine, and the other people are saying, no, they're like the meanings are already connected. And then when we think about the sentence as a whole, we derive the meaning from each word. But all this is kind of hand wavy, right? How can we actually describe how context influences meaning? If we have some vector for break, right, that represents the meaning of break over here, and the vase that represents the meaning of vase over here, when we put them together, they transform, right? When we have this verb phrase, break the vase, each of the meanings of these words clearly transform, as we saw over here, right? The input words have some elementary kind of representation, and when we get the output, we get like this contextualized representation that symbolizes the meaning of the word in that specific context. So how can we elegantly describe how context influences meaning? This is actually work that like this is a question that like I'm super interested in, and my work right now is actually investigating like my research at CMU. But just to give like a visual example, this is still from Chris Potts's slides. Here is the input layer embeddings for break, right? And each of these colors basically represent different meaning categories of break. So for example, all the purples represent represent the meaning of to like separate, when we're like separating things, but we're like the meaning of break such that we are separating things. For example, blue though is to like violate, right? When we're like breaking the rules. And red is like interrupt, like breaking the silence, I guess, or I don't know, something like that, right? So when we input these words into the sentence and they aren't strongly contextualized, sorry, when we input the word into the transformer, this big neural net, they aren't contextualized. So we have these individual sorry, like all the meanings are sort of overlapping with each other, right? There's no clear separation between these different categories of meaning of the word break. But when we put these embeddings through the entire transformer and we get out the top this contextualized representation of the meaning of the word break, we get this beautiful phenomenon where the meaning categories actively segregate into their various like subspaces. So for example, all the interrupts start converging on this same central kind of location of the meaning of the word break. And the separate meanings are over here, blue's over here, orange is over here. So all these contextual like meaning categories of the word break start pulling out and separating into these various regions of this semantic vector space. And you might be pointing at green and being like, what does that mean? It turns out the green is actually unclassified. So they show up in various different locations because they're sort of the miscellaneous bunch. So again, like the point that I'm making here is that these like in these big transformers, it's clear that somehow these like meanings are segregating into their expected like different representational areas based off of context. So based off of this evidence, I mean, it sort of seems like this contextualized embedding approach follows anvitabhidana, right? The words in the sentence each capture their contextual meaning. The meaning for break over here is dependent on and to an extent captures the meaning of the entire sentence, as compared to like the meaning of the words break over here. These capture like meanings of sentences that are about separation. So the Anvitabhidana school seems to be like on the upper hand over here. Perhaps we could use the opposing theory, Abhihitanvaya, to describe how words compose into a single sentence representation. So this is actually something specifically that I'm working on right now, exploring how syntax results in the composition of these words into a single embedding. So if we want to have a representation of the entire sentence, but just in a fixed dimensionality, in the same dimensionality as all our words, then this Abhihitanvaya theory might describe how those words compose into a single representation. There's also plenty of other psycholinguistic evidence studying humans that shows clear preference for Anvitabhidana. So for example, garden path sentences show how context influences the syntax parse. So if we have the meanings of each individual word in the old man, the boat, we won't be able to actually generate the correct parse of the sentence. Instead, we need to understand the meanings of the words in their context to actually be able to generate the correct parse. So like this is called a garden path sentence. A garden path is basically where as we're reading the sentence, we expect the syntax parse to be structured in one way, but it turns out to be structured in a different way. So this sentence says, "The old man, the boat." Um, does anyone understand the sentence? This is an easier garden path, so you guys might get it a bit more quickly. Like, what does this sentence mean? The old man, the boat. The old man, the boat. Any guesses? No? Okay. The old man, the boat, this is like man over here is a verb, right? We expect it to be a noun. The old man, right? We expect that to be an adjective. We expect old to be an adjective and man to be a noun. But it turns out that the old over here is a noun and man over here is a verb. It's the old men manning the boat. And we wouldn't really be able to understand this if it weren't for this contextual kind of meaning of each individual word. Um, so that's like this like some more reasoning more from classical like psycholinguistics that provides more evidence for this Anvita theory. Um, so that's like neural like NL like the connection I wanted to draw between Mīmāṃsā and neural NLP. Finally, one more thing that I want to say, slightly in a different kind of direction, but the same kind of underlying connection, is that like basically what we've been looking at here is like bottom up versus top down influences, right? The Abhitanvaya theory of the Bhattas is a bottom up theory, right? It talks about how these individual words combine together to construct a sentence meaning, whereas the Anvita theory talks more about top down influences. If we have some representation for the entire sentence, if we have like the entire sentence, how does that influence the meanings of the individual words? And this is actually an architecture, like a neural architecture, sort of conjectured or hypothesized by Jeff Hinton, one of the like forefathers of deep learning, just last year in like this huge like 40-page kind of paper that he dropped on arXiv. And basically what this is supposed to do is to reconcile these top-down and bottom-up influences. So this is kind of like the architecture is sort of hard to understand, but the basic idea is that we, from each level, from like one level below, we get like some bottom-up representations, and then we feed it up to the current level, and from one level above, we get the top-down like we put it through this like top-down representer net, and then we feed that into the current representation. So in that way, we get this like percolation of meaning from both the top and from the bottom. And on the right over here, this is like the more kind of intuitive diagram, I'd say. So at the bottom over here, we have these individual word vectors, which start out very differently, right? So like, for example, this could be like the old man, the boat, period. I don't know. Let's say that these are just a bunch of words, right? As we put them together, as we process them through this Glom architecture, the meanings of the words actually converge on these vectorial islands. And these vector islands are supposed to represent syntactic like subcomponents of the entire sentence. So for example, like if we have some phrase over here, right, like the old, those will converge upon the same representation. The old both converge upon this same kind of meaning that represents the meaning of this entire phrase, the old. Man over here could be like would just go to its own thing, and then the old man like combines. I'm using like a bad like word example, but the general idea is that implicitly in these vector islands we get like this syntax parse, where at each level of the syntax tree we have this set of vector islands that are like converged, combined meanings of all of their subcomponents, such that when we get to the very top of the syntax tree, we arrive at this unified meaning that represents the entire sentence. And this entire sentential representation is implicitly encoded on the embeddings of each word, right? If we follow one word through the entire architecture, we arrive at this sentential meaning. So this is like another kind of view that sort of seems to favor the Anvita school, the Anvita theory, because implicitly on each word we have the representation of the entire sentence, the meaning of the word as it's connected with all the other words. So that's the last kind of thing that I wanted to say in terms of content. broader kind of takeaways here is that like the Sanskrit tradition like deeply influenced the rise of Western linguistics, right? We saw how it was basically an expectation for most serious linguists to be well versed in Sanskrit until about the 1950s. The founder of the Berkeley Linguistics Department, the developers of structural linguistics, historical linguistics, were all like basically experts on Sanskrit. We then saw how the Ashtadhyayi used like sophisticated symbolic formalisms that are still in use by computer science today, nearly 2,500 years ago. Things like meta rules, scope hierarchies, like syntax parses, were all developed in the Ashtadhyayi. Then we talked a bit about the connections between this two theories of the Mīmāṃsā school and modern issues in vectorial semantics that are being discussed by literally like Stanford professors at like the most cutting edge conferences last week even. And we saw like the very kind of tight connection that there is there. And then finally, I guess like on a more personal note, like the centrality of language they need intellectual tradition, right? All the way back to the Vedas, there's like verses focusing on like vach itself, right? Vak, like the word, and like the beauty of language. So for like the entire history of the Indian intellectual tradition, like language and the study of linguistics has been like super central to basically every domain. There's like these six kind of disciplines called the Vedangas, sort of like the underlying basis of like a liberal arts education in the traditional Sanskrit intellectual tradition, and four of those are linguistic oriented. Like it's like phonetics, semantics, like morphology, and like poetics or prosody. And like the centrality of language sort of like gives very grand context for my research, right? My research, which to some people seems like, oh, it's working on some like nitty-gritty kind of issue in NLP today. To me, that's like in conversation with discussions that have been going on for 2,000 years, almost 3,000 years. So it endows my work with a lot deeper meaning. And like to me, that brings like a lot more satisfaction when I'm working on these problems, right? Because it's not just something that's going to be blown away by the next state of the art kind of paper in a year. It's something that is like in this grander narrative that's been going on for thousands of years. So yeah, that's about it. Here's some sources. This is the Chris Potts talk from last week. This is the Jeff Hinton paper where he proposed that Glom architecture. Then this is the thesis that I brought in a lot of sources for discussing Anvitabhidhana and Abhihitanvaya. This is the Transformers paper. This is non-contextualized word representations. And then this is where I drew some of the connections between Pānini and Ashtadhyayi and like computational theory from. And then finally, when we were talking about uh, uh, the various sandhi rules for explaining that vowel sandhi, like the vowel sandhi, that came from learnsanskrit.org. He's anonymous. I think I know his name. I emailed him once. I think he works at Google now, actually, but he's developed this very great resource for learning Sanskrit, if you're interested. But yeah, that's about it. Thanks, yeah. If you have any questions, I'm definitely feel free to take them. Cool. Looks like we lost a few people, but maybe a bit too fast-paced. But yeah, at least we'll have this recording. I'm sure a lot of people will love to grab that.